Okay, so the last little video is just titled it Trigonometry. We're just going to be solving for random triangle business, okay? And the hard part here is you won't get to see my calculator, but hopefully we get the same answers. So we're supposed to find angle A given that B is 34, this is a 9 and this is an 11, okay? So the reason I drew it like this is only because I noticed that it's an a side-side angle, and with a side-side angle sometimes you could have two possible triangles. So let me work through this and see if it's only one triangle or two. I know I'm supposed to find A, so let's just find that first. So we're going to do a law of sine. So I'm going to first set it up as the sine of 34 over 9, because you always want to go opposites here, equals the sine of A over 11. And I'm going to do a little cross multiply and solve. So really my sine A, I'll be typing in 11 sine 34 all over 9. Make sure that your calculator is in degrees, okay? Very important that you're in degrees, or this will make no sense at all. And you're going to type in the 11 sine 34, and when you divide that, you're going to get this small number, 0.6834. Okay, now 0.6834. This is going to look weird, but remember, we're looking for an angle. So once you get to this point, you are going to type in the sine inverse to find the angle. So if I do second sine on my calculator of my answer, I'm getting 43.11. So I know that A is 43.11. But I'm not finished, because since this is a SSA, I'm going to check to see, is there a second angle A? Is there a second triangle out there? And the way that you do that, or here's the way that I do that, is I put my 43.11 in there, okay? I take that angle that I just found and I subtract it from 180. And 180 minus 43.11. And so I got 136.89. Now that 136.89, that might be a second option for A if and only if I can take that angle, add it to the given angle, and there's still room for a baby C. So remember, a triangle has 180 degrees. So if you can take this supplement and add it to 34, is it less than 180 still? Well, 136 plus 34, that's going to be like 170 something. So yes, there would still be room for a baby angle up here, which means there would be a second triangle, folks. So this is not the only option. I mean, this is one of the angle A's that the calculator gave you, but you're going to have to know, if it's an SSA and all this crap can happen, that you can find a second angle A for this triangle. So ambiguous case is a lot of fun, but luckily it only happens only on an SSA. Okay? Alright, now we move on to 16. Find little c given angle C is 120. I'm going to stick that up there because it's big and obtuse. And A is 6 and B is 9. Okay, so this is a side angle side. And if you try to do law of sines, you're going to have too many missing pieces. So that is why the law of cosines exists. And so the way I have law of cosines memorized is like this. Alright, and pretty much I memorize this version and then I look at my picture because the angle that's at the back here is the only angle that's given in the picture. It's the included angle. And so I know that if I'm supposed to be finding the thing across from it, which in this problem I'm supposed to be finding this side, that's going to be the unknown at the front. And then B and C are just the sides that surround that angle. So I'm going to plug it all in. I'm going to call this a little c instead, and then this will be like A and B. So 6 squared plus 9 squared minus 2 times 6 times 9 times the cosine of 120. And I love these problems because I'm going to type it into my calculator in one big string just like this, okay? I mean, I'm not doing it step by step. It's going to look identical to that. Minus 2 parentheses 6 parentheses 9 cosine of 120. And you're going to get, I'm going to get 171 is what I'm getting. So 171 is really big, right? Well, that's because I haven't taken the square root yet. That's a really pretty number there. 13.08. Alright, so that's how you do a law of cosines. And there's more versions to these, so you've probably seen them in class, but, you know, be good at these so that they could be easy ones to get right for you, okay? Now find the area of both triangles in 15 and 16 above, okay? So I'm going to find the area of the triangle. In number 16, it's all ready to go for me because you should have been given this formula from a teacher, and I already have all of these. I have big angle C, I have little a, I have little b, so I'm just going to type in exactly like I see it. 1/2 of 6 times 9 times the cosine of 120. So that's going to be cosine 120. Alright, that's going to be negative 13.5. Oh, that doesn't make much sense, does it? Oh, duh, it's sine, not cosine. Haha. I keep doing that. Okay, so it's going to be sine. Alright, how about 23.38? That sounds a lot better. 23.38. Awesome. So that's the area of the triangle above. Alright, oh, and it also says to do number 15. If you want to do 15, gang, you are going to have to find this angle first. I'm actually not even going to do it. But you always want to use the angle that's between the two sides that you know, kind of like it was here. So I know this 11, I know this 9, so just do a little math from 180. You know, 180 minus this, 180 minus that. That's going to find you that angle up here, and then you can run the same exact formula, okay? Now, number 18, find the arc length and the area of the sector given in a circle with a radius of 3 and an angle of 22 degrees. So I'm just going to draw like a little, there's the picture in question. So it wants arc length and it wants area of the sector. So how do I do arc length first? Well, arc length is usually labeled with an S, and it's just, what is it, R over theta or something like that? Yeah. So when you have that, it's just, the only key is, or the only trick, is that your theta needs to be in radians, not degrees. So to find arc length, I'm going to do the radius of 3. And for my theta, I'm not going to put in a 22. I need to convert it first. So to convert it to radians, you do pi over 180, remember? So it's going to be 22 pi over 180. And from here, you're going to solve. So I'm actually just going to reduce the 3 and the 180 first. And that would be a 60, and then let me cut those in half. So I'm getting 11 pi over 30, and that would be the arc length. Alright, for area of a sector, the formula is 1/2 r squared theta. Same thing though, guys, you want the theta to be in radians, and since we've already found it, it was 22 pi over 180. I'm going to solve it like that. So we're going to have a 1/2 times 22 pi over, let's see, that's a 9 and a 180. And if I reduce 9 over 180, I think I'm going to get a 20. So I'm getting 22 pi over 40, which is 11 pi over 20. I'm pretty sure I did that right. Let me know if I didn't. But that's how you would do area of the sector. So there's a little taste of some stuff that could be on your final. Hopefully you have a review from your teacher, you read over your notes, and then you'll be good to go. Alright, thanks. Let me know if you have questions.